Welcome back to Ox Tools. I'm Tom. So I got so much meatloaf here, I don't even know what to do. I've been in a little bit of a funk and haven't felt like shooting video. Just felt like doing a little bit of work in the shop, listening to some tunes and just kind of rocking out and keeping to myself. So I apologize for those of you that really enjoy the meatloafs. I got a ton. I've got trays and trays of it. So let's take care of some meatloaf and look at some of the things that I've been working on and stuff that's in the shop. All right, this next one's pretty cool here. So what we got here is, this was loaned to me by a friend of mine at work, and he watches the show and is intrigued by some of the things that I show. And he said, "Hey, listen." And keep in mind, I hadn't seen this yet. He says, "Hey, I got this this drill press vise that you might be interested in showing on your channel." So I don't know about you guys, but you know, when I think of a drill press vise, this is kind of what I think of as a drill press vise, right? It's not a very nice vise, right? So he's telling me this thing, right? He's going, "Oh, I got this drill press vise that's really nice. I bought some tools from an old shop, blah blah blah, and you might want to show it on the on your channel." And I was, you know, I was trying to be a nice guy and go, "Well, a drill press vise, huh? Yeah, sure. Well, yeah, maybe." So I don't know. It's been going on for a while. So I said, "Well, why don't you bring it in? We'll take a look at it." So boom, he pulls this thing out of the box, and I said, "Okay, hold on a second here, pal." I said, "This is not a drill press vise, okay?" And what I call this vise is, I call this a Jig Bore style precision vise. And I'll show you why in a minute, because somebody asked me, they go, "Well, what makes it a Jig Bore vise?" And this style is just associated with jig bores, there's nothing that makes it a jig bore vise. It's just, you know, there's some literature and some pictures in the industry that show some vices of this configuration that are on jig bores. So now, this vise was handmade. Okay, this is a shop built one, and it was built by a fellow named Ed. I'm not supposed to use his last name, which is fine, no problem. Ed's still alive. And he might not want to be mentioned on camera. So anyway, Ed worked for a guy named Clark Mitchell, and who is deceased, and ran a company called Manor Research in San Leandro. And so this is a tool and die shop, or a precision machine shop, something like that. And in fact, there's some initials in here, and this is a Clark Mitchell, right? I don't know what the S is. But so anyway, Clark owned this machine shop, and you know, when times were slow, instead of laying guys off and saying, "Hey, come back in a week," or whatever, or a couple of weeks or whatever, they kind of, you know, turned inward into the shop and made tools and tooling that was useful in the shop, right? So, you know, he'd keep paying his guys and use some of the steel that was laying around, left over from jobs, to build really nice tools and stuff that they could use, you know, in their regular work. Excellent tradition, okay? Nowadays, you know, if there's a whiff of a downturn, they just cut people loose and send them packing, and then, you know, call them a month later and say, "Hey, can you come back?" And it's like, "Nah, I got another job, man." So, anyway, enough of that. I don't want to get off on a tangent there. But, so what we got here is we have a copy of a Producto. Producto vise looks very similar to this. It has this latching mechanism and this kind of quick action like this one. And this is not a thread. This is just a, let's see if we can get it to drop in there. This is just a coarse adjustment to get it close. And then it has a thread here that you can see here in a sec here. I'll try to show that. And this is a left-handed Acme. It's a 1/2 10 Acme there. that threads into the inside of that. Okay, so pretty cool. It's about 5 inches, about 5 inches width there, 127, 25 millimeters, something like that. And it opens up about the same all the way like that, okay? Although you got to get the latch on there to get at the clamp, so I think that's the last increment there, right? And then you can open it up. And the attention to detail on this is really nice. It's just beautifully made. This particular, the moving part is slightly higher than these surfaces, so when it's clamped down on the machine, this will still move, which is kind of nice. And I don't know if any of the grinding folks out there kind of noticed, but let's see if we can show it here. So these are the bars here, and you can see the outline of that. And these are dead sharp corners in there. There's no reliefs. So not quite sure how they did that, if he ground it or if he just machined this part, the block first, and then ground the bars to fit that really closely. Not sure kind of the order of operations there. That's probably what I would do, is instead of trying to grind a dead sharp corner in there like that. But, and it's the same on this end too, pretty nice. Beautiful chamfers, they meet in the corners, it's lovely. Nice knurling. I mean, it's just, professionally made, okay? Now, so my friend John loaned me this so I could show it on a Meatloaf, but what I've done, and it's not quite ready yet, is I've measured this all up and I modeled it up in SolidWorks. And so folks out there that might want to build one of these for themselves, I'll have some PDF plans that I'll be able to send out shortly. So if you're keen on that and you want to make one for yourself, let me know, shoot me an email, and I would be happy to send you a set of PDF drawings for this, right? Oh, we got a little bit of corrosion there that needs a little attention. So, but just absolutely wonderful there. So, Manor Research Jig Bore vise, we're going to call this one here. So, and John, thank you very much for loaning this and let me show it on the channel. I just had fun kind of fondling this and playing around with it. And I think, my only criticism of this vise so far with playing around with it and handling it is the method that this threaded screw is retained in this. So the threaded screw is not turning. This turns around the screw. And what he did was there's a roll pin here, and you can just see the halo of it right there, and that's driven down in and into that pin. But there's no, you know what? I'm going to shut up because I haven't taken this bar off, and I kind of don't want to take it apart because it's John's vise, and but if I was doing that job, so you know what? I'm going to give Ed the benefit of the doubt, so that he drilled that all the way through so that you could take this apart if you needed to replace that screw or tune it up or do something. So I'm willing to bet money that when you take that plate off, that hole goes all the way through. And I'll tell you what, when I model that particular hole, I'm going to make it go all the way through. So if it's not that way, it will be that way in the future. So John, thanks very much for letting me play around with that, and I'll get this back to you very, very soon. So thanks again. I almost forgot to show this. So this book here, this is the book by Moore, Holes, Contours, and Surfaces. If you don't have that, you should get a copy of it. It's just a pretty cool book, kind of old-timey jig bore practice and stuff. But here's the style of vise that I'm talking about, and this is a Moore version of this type of vise here. Now this one has so it's got kind of a dual screw. So I think the way this is working is they have a left hand and a right hand thread, and so this is kind kind of increasing the effective lead there, I think is what's going on. I've never played with one of these firsthand, so I'm not quite sure how that works, but it doesn't have the same kind of notched quick change arrangement as the Producto style. I'm going to call that the Producto style because that's pretty indicative of that. And you know, basically it's a precision vise that you can put down on the table, and then if you have a bunch of parts that are kind of the same form factor, it's just a little quicker than dogging them down with toe clamps and stuff like that. So but these show up on Jig Bores. You know, I've seen other pictures too of this type of vise here. Some you see, instead of rectangular bars, they have round bars. And I've heard stories about how they make those is to get them to be really accurate and run really smoothly, is they actually pot the rods in an oversized hole so that they get the centers just kind of exactly matched to the parts, so that they run like you know, greased lightning, you know, super califragilistic there. Because you got a bunch of holes, you know, you got, so if these were rods, right, you'd have 2 holes in this, you'd have 2 holes in this, and you'd have 2 holes in this, right? That you would have to nail those centers really accurately to have, say, a press fit, right? And have this thing just operate beautifully, right? Now, there's ways of doing that, but in this particular case of where I was reading about that, they, in the end plates, I think they just potted them so that they were held in exactly the right position for forever. Okay, anyway, so holes, contours, and surfaces, and Jig Bore vices. I think we have talked this one into the ground. So this thing showed up in the mail, and most of you guys know what this is. And I guess I have mixed feelings about this. This is my 100,000 subscriber, you know, play button from YouTube. So what do I want to say about this thing? Like I said, I kind of have mixed feelings about this, and partly because I had to basically harangue these guys to send this thing to me. And that really kind of annoyed me because, and here's why. You know, we're the content producers, right? So we produce everything that they produce nothing, okay? But they're reaping the lion's share of the benefit from the content that we produce, okay? And so, you know, their signals of appreciation should be automatic, okay? So when you hit 100,000 viewers, this thing should just show up in the mail. Surprise, okay? You shouldn't have to ask for it or beg for it, and which is kind of what I did, right, I guess. You know, I emailed them, nothing, emailed them again, nothing, and then I gave up for about a year. And then somebody said, oh, well, this person was able to help me. So I emailed them and then finally got the thing. So like I said, I kind of I'm a little bit pissed off, you know, having to beg for the stupid thing, okay? So the content we produce makes them billions of dollars, okay? And the tiny itty bitty tiny little slice that they give us, okay, for content creators is just infinitesimal, right? I mean, Tony Soprano gives a better split percentage than YouTube does, okay? So working for YouTube is worse than working for the mob, okay? So let's just put it that way. Anyway, I don't want to whine about it, right? Okay, yeah, it's cool. I got to 100,000 subscribers, right? And yada yada. That's kind of neat, and it's opened a lot of doors for me, and so I'm appreciative of that. But I'm just pissed at YouTube for being basically an impersonal bunch of pricks. Okay, so enough said. Let's close this stupid thing up and move on to something more interesting. This little box of goodies, I can't even remember who sent this here. So, let's make sure he's okay with us. Yeah. This is Mike Tarab, and he sent me a little goodie box here of some interesting things. Let's just take a quick look. Got a little cast iron anvil there, kind of neat. This is a New Britain half-inch breaker bar. That's pretty old school there, kind of neat. And then, oh yeah, now I remember. So these are kind of cool. I just love these, the cast wheel here. You know, it's got this double curved spoke, and it's got a lot of spokes, which is kind of interesting. This is Miller's Falls, and it has, I believe, yeah, okay, it's got some little drill bits in the rear end here. Wood threads, kind of neat, right? This one seems to be intact, right? A lot of times these in fact, this one looks like it's had some problems here, but a lot of times these are broken, right? I had one of these before, but my wife snagged it because she really liked the wheel off of it. So these are kind of cool. You can stick a countersink in them, and then just keep them around the shop, and you know, you can grab it and countersink a hole with it or whatever. So pretty cool. And that's total old school there. Okay, a Mac wrench. Now this is really old, so maybe some of you folks out there know. This says Mac Sabina. I don't think it's the guy's name. So I don't know what the history of Mac Tools is, if they had a partnership prior to them just being Mac. So this is 3/16 and 1/4 inch, and you don't see a 3/16 wrench typically this long. So that's pretty gnarly. So that's Mac Sabina. Maybe somebody can look that up. Now this is the main thing that he sent, right? And those longtime viewers out there that I did a video, oh gosh, it's probably 8 years ago now, where I repaired a putty knife like this. And this is just a shitbox, or excuse my French, a dog meat putty knife. My mom has one like this, exactly like this, right? This is a Warner. And anyway, something happened to it. The spot welds came loose or whatever. Anyway, I fixed it up for her, and I made a big deal out of the video. And she was so happy because that was like their favorite putty knife, right? It has just the right spring and all this, and she just loved it, and she just thought it was great that her son fixed it up for her or whatever. So this guy got a kick out of that, and he found another one, and he sent it along. So that's the story behind that. So, and then we got some carbide inserts here, kind of random. Although these look like I can use them here. These are WNMG with a PP chip breaker. That's one of my faves. And there's some threading inserts in here. And these are like shockingly expensive. So we'll examine those under the microscope and make sure they're in good shape and check those out. So that's kind of cool. And then we got some, what are these? These are some weird collets. Oh, what is this? 7B. I don't even know what that goes on. I got nothing that fits, so those are going to go in the trade box or whatever. And I got a bunch of those. Those are hard-inch collets. Those are nice collets. And then some drill bits, or excuse me, some router bits. Nice carbide grooving tool. That's pretty sweet. Carbide blanks. And oh, some itty-bitty little carbide end mills, 15 thou, scary size. Okay, let's get rid of that. And maybe we'll go look at one of these on the comparator. That might be kind of fun. Oh yeah, look at that. You can barely see it, right? There it is on my fingernail. I mean, sometimes getting these little tiny tools out of the package without breaking them is a challenge, right? So hey, Mike, thanks for sending this stuff. This is great. Sorry it took so long to show it on camera. Like I said, I've been kind of busy and kind of in a I'll just call it a bad mood for a while, but I think I'm back on the horse. So thank you very much for sending this in. This is great. All right, we're going to take a look at this this itty bitty little 15 thou 2-flute end mill just for fun. Somebody had asked what the magnification on this. Let's bring it back to 0 here. What the magnification on this particular comparator was, and the answer to that question is it's variable. I have, I'll take this one out here. It has different, so this is a 20x lens here, right? And I have several all the way up to 100x. Oh, that one's kind of dusty there. Where's my, so anywhere from 10 to 100x. Blow that off real quick. So we're just going to use this 20x here to start with. Remember which way it goes there. There we go. Okay, we'll fire it up. And then I'm going to put the end mill. And this end mill, you can't even, so there it is, right? You can't even see it, right? So let's clamp it down first. And we'll get it in the, okay, here it comes. Here it comes. And there's our, let's see, I'll probably have to rotate it a little bit. There we go. Alright, so rotate it a little bit, focus it, get it nice and sharp. Now if I want to measure this, for example, alright, I'll turn on my little DRO here. And then what I'm going to do is I'm going to bring the edge of that end mill up to that line, just as a reference. Sneak up on it. Okay, it looks pretty good. And then I'll zero that. And then I'll just go to the opposite side. That looks pretty good. 14.9. So that's one way you can measure things like that. And then you know, I can measure the length too if I want to do that. But let's do this just for fun. Let's swap this lens out. I don't want to stab myself with this stupid pokey thing. Let me, I'm going to stick the, let's put the 100x in there. And you guys will get a sense of the difference there. I mean, you know, it's, you can kind of understand the difference, right? But when you see it kind of firsthand, it's kind of fun. So, all right, so there's 100x. Let me get this back in the field of view there. Okay, there's 100x. So let's see. I can. Oh, that's the side light there. I'm already on high there. So there's 100x. Let me sharpen that up a little bit. Okay, so that's 15 thousandths. Now, if you have an overlay chart like this, right? These are typically set for a particular magnification, so then they redirect. Otherwise, you got to do a little multiplication. Anyway, so that's how that works. All right. So this is a cool book here. This was loaned to me by a friend of mine at work, Steve Halleck. And it comes from a friend of his, and his friend's name is Dominic Lucero. And Dominic saw my video when I showed another Braun book. And for those of you that missed that video, it was in a Meatloaf. And Braun is a kind of a petrochemical fabricator. They make heat exchangers and pressure vessels and all kinds of stuff related to oil refining and whatnot. They're since out of business. They started in Oakland, and then they ended up in Alhambra, California, which is Southern California. And the other really interesting thing is I put some pictures, some of these where I have flagged here. I put them on Instagram, and the great-grandson of Mr. C.F. Braun contacted me and said, "Oh my God, this is amazing! My family history is on Instagram." He just thought it was cool, and so anyway, I chatted with him a little bit. So there's still relatives floating around, but let's look at some cool industrial pictures. This is once again, it's kind of a company catalog. And it's just full of real interesting pictures here. So we got the weld shop here. You got their little welding areas here. Lots of room to work. This is a nice weld shop there. That's pretty clean for a weld shop. And then here, some plate rolls. This style is called, sometimes called a pyramid rolls. It's got 2 lower rolls and 1 larger upper roll. And these are roll supports here for these smaller rolls. And then what happens when you roll a cylinder up on this, when you close the gap on the cylinder, this end hinges down. In fact, that's what this little rod is for right here. As that whole end swings down, and then you slide the cylinder out, you grab it with the crane, and then you sling the cylinder off of there. So pretty cool. And then, so they're hot rolling a head on there, 1,000-ton press, squashing a vessel head out of there. Yeah, this is heavy industry at its best, right? VTLs. So this shop had literally dozens and dozens of VTLs and radial drills too. Oh, this thing's pretty cool. That's why I have it flagged. Duh. So what they did here is, this is a boring mill. This is a little Lucas, or not sure what exactly, a boring mill that they've converted. And so what they've done is this is the rear support here, and they've mounted a beam here. And in that beam, it looks like there's a gearbox that rotates, a frightening looking trepanning arm here. So what they're doing is they're trepanning these circles out of here, right? I don't know if that's a clamp, or I don't know quite how this works. That looks like the cutting bit there. I'm not positive though, it's kind of hard to see. But yeah, circle cutting naval brass tube sheets. So a tube sheet is basically a round plate with a whole bunch of holes in it. That's like a tube sheet there, round plate, lots of holes. So yeah, once again, lots of drilling equipment for doing that kind of stuff. So here, this gives you an idea. This is probably not super happy work filling these bundles here. There's literally thousands of tubes in there that you have to pass through all these tube sheets that support them, and then at the ends of these, they swage the ends so that they form a seal on this last sheet here. And there's different names for the, these are dividers and these are end plates or something. Yeah, there's terminology there that I'm not familiar with, but basically they swage that tube around. There's a little groove around the that hole, and they swage it and it seals it. So it's kind of neat. Pressure testing them, make sure they don't leak. Lots and lots of tubes, right? So let's see. Let's go to this last one that I have here. Oh, yeah, this one's pretty cool. So, we were talking about layout, right? And, we laid out that pentagon recently in a Meatloaf, or it was a Meatloaf question and answer is what it was. And we were doing a little layout here, right? Well, here, this is a layout bench, right? You got the old codgers there, well lit. He's got a square and his hammer, got his little dividers there, a trammel, and a nice wood slats to stand on, and so they're doing some fancy layout there. So anyway, what does it say? Tube fields, huh? That's an interesting term. I'm not familiar with that. So Dominic, thank you very much for loaning me this book. I'll get it back to you soon. And Steve, thanks for bringing it in. And this is very cool. And the great grandson of C.F. Braun thanks you. All right. So this is pretty cool. This comes to us from North Carolina, and a gentleman named Steve Heglar, and he has a bead roller, and he saw this sticker in the background in some of the shop videos, and anyway, he thought it's, he gets the joke, right? The no bozos joke, right? This all started. The bozo thing started with a guy that I work with at work, and he said, "Yeah, I bozoed that," or "Don't be careful, don't bozo that," right? And so it just kind of stuck, and we started using it, right? And anyway, it's pretty funny, and I found some stickers. And anyway, Steve sent this. Well, thank you, Steve. This is cool, and I'm gonna hang this up in the shop and somewhere because it's kind of neat, right? This is great shop art. So thank you so much for sending that in. I really appreciate it. It's always really nice to get a handmade gift from somebody. All right, this next lot is kind of interesting, and it's from He Who Shall Remain Unnamed. Back in, they are back in Detroit, I can tell you that. So about all I can tell you. Anyway, they sent me a goofy package here with some stuff in it. We'll crack it open and take a look at some of these things here. Oh, that's nice. Look at that. They wrapped this in. In this special paper that, what do they call it? Volatile VOC paper or something like that. Okay, these are Starrett. And this person asked about these hold downs, and we'll talk about these hold downs a little bit here. So let's get that out of the picture there. Get that out of there, and then we'll crack this open. So that, there's the note. Put the cardboard to good use. And what we got here is a little cartoon book on measuring, and then a Lufkin catalog, which is kind of neat. And then, so the Lufkin catalog, let's do that one first. It's pretty, Lufkin makes some really nice stuff. So if you're not looking at Lufkin stuff on eBay, you should be. It's pretty nice. But there's these hold downs. So all these guys, Starrett, Brown and Sharp, Lufkin, they all made a lot of the same stuff, right? And then these are made by Starrett, these particular ones. These are Starrett, wow, 004s? Huh, interesting. Oh, 54s. 54. Number 54. And then these are the Lufkin versions, so, okay. And then we have this cool little book here. It's just kind of a comic book, copyright 1960, and basically talks about some of the historical figures in the history of measurement, right? Back to very, very early times, right? Caveman stuff, right? So what did the caveman do? Since time began, body became a yardstick, blah, blah, blah. 6000 BC, the cubit. I think there's a picture of Robin Renzetti in here in the back. A father of measurement. So we'll just call him a father of measurement. So he's our father of measurement. Let's our time period here. Anyway, kind of a cool book. And I love these kind of rabbit holes here, right? Because you can actually, you're going through this and you go, oh, wow, I didn't know that. And then you kind of dig in and you start looking at some of these things, and they're rabbit holes that you can kind of, or rabbit warrens that you can go in and kind of poke around and learn some stuff, and just kind of understand a little bit more about the world. And anyway, pretty cool. I'm not going to go through a bunch of stuff here. And it has, I think, yeah, we had Johansson and John Quincy Adams. What did he, Pro and con recommend that no change be made. All right, whatever. Okay. Anyway, kind of neat. And we got hold down, and then we got these funky clamps. These are like old school toggle clamps here, right? Basically, you see these at the flea market, and I don't know of anybody that really uses them anymore. Although people probably have them and still use them. This one's screws locked up on that one. I don't know. They're just, well, let's try one. Maybe I should quit yapping and give it a try. I mean, it's basically like a pair of vice grips, right? Yeah, okay. Pretty unsatisfying. It feels like it wants to twist sideways on me. Yeah, in fact, it's tweaked, right? Because somebody wailed on it, right? And they want to cam over. I guess it works. But look at that. It's not even clamping straight, so I think that's a fail. All right, let's look at these these hold downs, and let's go over to the mill. Actually, let's try them in the mill. So these are actually a little bit tricky to demo here, but we're gonna try here. I think I got something that'll kind of illustrate how they work. So back in the olden days, before you had a vise like a Kurt here that has a mechanism that literally forces the jaw downward, right? They were basically, I don't know, kind of like T-slots or dovetail kind of arrangements, right? So what tends to happen is when you clamp something up at the top of the jaws, they kind of splay open, right? So you're not really gripping your part real well. And so they kind of came up with these things here to help with that problem, right? And for those that don't know, these have a couple of very shallow little angles on them. So this isn't 90 degrees here. It's got a little angle to it, and so does the nose. And this was a real common kind of apprentice project. First project was to, on the shaper, make some of these hold downs, right? But we're gonna kind of demonstrate them here. So, and there's potentially they still have. I haven't used any in like 1,000 years, which is not that long ago for me, but. They're intriguing because they only have a 1/16 or so, a little over a millimeter, kind of gripping surface down there, so you can get down real close to the bottom. So let's try it out here, and we're gonna just grab this block, and I'm gonna put a little piece of paper underneath it, right? And the idea here is we'll put that in there. Like so, and then we'll tighten the vise up. And I'm not going to push down or anything like that. So the idea is that angle, what it does is it forces those jaws kind of in a downward, in kind of a downward movement, right? And thereby pushing the piece down. So let's give it a little. You might have seen that. Actually, let's do that again, right? So you see that it's coming up because of that angle. Same thing there, right? All right, so let's do that, right? And just right out of the gate, that paper is clamped tight. So I'll crack it, I can move the paper, clamp, paper's tight, right? And actually, let's do this here. I'm gonna put what I think is reasonable force on there. Let's give it a, so, I don't know. I mean, I'm not wailing on it, but it ain't moving either. So that's fairly impressive, actually, for a little over a millimeter gripping on each side. So hey, those are the Starrett hold downs, or Lufkin, or Brown and Sharp, whatever. These are, I think I mentioned, Starrett number 54s, and so you see these all the time at flea markets and stuff like that. So if you want to play around with those are pretty cheap on eBay too. So, all right. So this next one, it's a little grab bag of goodies from a guy named Winston Ditlow, and he runs Godshall's Custom Machining. And I bought a T-shirt from them. just to support him. And he's on, I'm pretty sure he's on Instagram, and that's where I saw him. And has a little shop, and they do some model train stuff and all kinds of interesting things. So welding and fab, that kind of stuff too. Anyway, I sent him some stickers just for fun, and he sent me back a little reciprocation package that's of interesting things. So I guess he also does laser engraving. That's all done with a little fiber laser there, right? And if you have an image, you can mark your parts, or you can burn wood, or I don't know if you can cut. I don't think you can cut wood this thick, but you can certainly burn the hell out of it. So anyway, there's that. He sent me this old scale. This is a Brown and Sharp with the swirly wavy logo or whatever, right? And I guess he got a new one. This one has kind of the patina of a lot of use on it, right? So slightly rounded ends, polished, and just smooth everywhere, right? Because it's just been handled by rough hands for many years. And this has the end graduation, which is also my preferred. So there's my daily carry there. And this one's not that old. I broke my. I had another one like this that I broke. Oh God, that's 20 years ago now, probably. Let's see, when is that? That's at least 15 years ago. I broke it in a press brake. I was gauging something, and I came down a little too far. It snapped a little piece off of the ruler, so I had to get a new one. And I was bummed because the new one was all sharp and real pokey, right? And it takes a few years for it to kind of round off a little bit like this one. Oh wow, that's a slightly different width. Interesting. Okay. Huh. Anyway, Brown and Sharp makes nice stuff. This is the 4R graduation, that's Starrett's designation. I think that's what this one is too. This is a 4R. Yeah, 604R they call that. And I don't know what Brown and Sharp calls that one, but this is the old logo. And he also mentioned this little stain right here. I don't know if that's showing up on the video camera. There's a little heart-shaped stain that he said caught his attention every time he used this. He would look at that, and anyway, I'm just glad he told me about it. It's kind of cool. All right, and then he sent a single gauge block here. Okay, this is a Brown and Sharp gauge block, but it has a calibration to plus 1/1,000,000th. So now what that means is when they're measuring them, they just segregate the ones that are in this particular range, and they charge a little bit more for them, I think, is what they do. So we'll leave that one in the package. There's no reason to take it out. It's kind of an oddball size, 600 thousandths, but and it's of the square. Excuse me, the square type, or Hoke, Hoke type. Pratt & Whitney also made them like this too. I kind of like these because it has a center hole, and you can screw them together and make fixed gauges that are a little more user-friendly. And but they're not good on they're not as good on comparators because you can't set the probe on the center. You have to set it off to the side. So. Rectangular ones are generally better for comparators. Anyway, nice little gauge. So thanks, Winston. And then this cool little tape measure. Let's pop this guy out because this is kind of neat. I don't want to wreck the box here. This is an old Stanley. Well, it's not old. It's a new old, right? And this is it's round. So this is a great one to put in your pocket, right? Because it's round and kind of smooth, right? And as opposed to the kind of squarish ones or whatever. Anyway, it's kind of a nice tape measure. So Winston, thank you very much for sending some goodies. I appreciate it, and I wish you the best in your business. And I wear that T-shirt probably once a week because that's the laundry cycle. So anyway, thank you very much. Okay. This little group of goodies comes to us from a guy named Jeff Wright, who's in San Antonio, Texas. And Jeff is an engineer, and I guess he had these instruments kicking around, and he thought they might be fun to show on a Meatloaf episode and do something with them. So he sent them in, and let's check them out. So let's set that one aside for a sec. Let's take a look at these here. So what the heck are those, right? That's what you're thinking. Well, what these are, let's see, is there a label on the side of any of these here? Yeah, these are called pie tapes, okay? And what these are these are for measuring large diameters, and they use the principle of converting the circumference into a diameter. Okay, so it has a little bit of leverage there, 3-to-1, something like that. So, so this one here, this is 2-inch to 12-inch, 12-inch to 24, and then this one is, oh wow, 3/4 to 6. Okay, let's take a look at that one there. That's actually probably a good one to look at there. And let's pop one out, and you can take a look at them. And what they are is they're steel tapes. Okay, if you've never seen one, and they have this cool little joggle in them here, like this. Okay, and it has a vernier on it, or vernier, depending on how you pronounce that particular word. And what we do is we wrap this around like so. Okay. Let's see if I got it going the right. Oops, no, I don't have it going the right. I gotta look at it right side up here. Okay, so it's like that. So you wind them around apart, and this is probably hard to see here, and maybe we'll set something up. And where we, oh God, this is hard. This is a pain in the neck here to do upside down. Okay, anyway, you wind them around the part, and then you fish these around until you got good contact all the way around, and then you read the diameter. You read the diameter. It's probably almost easier to put it on something. You know what? I think that's what I'm going to do. All right, oh, here we go. Now I got it pretty good. Okay, so let's just set it right at 6 inches here. Okay, so that's a 6-inch diameter. So it has a vernier, a 25 division vernier, right? So it'll read to a thou. 1, 2, 3, yeah. So it'll read to a thou. Okay, and so that's 6 inches, 6.1, 20, and then 6-inch 25,000, 6-inch 50,000, 6-inch 75,000, 6.1, right? And what's neat about these is you can measure really large diameters, right? Like I have some that go up to 48 inches, right? And a 48-inch micrometer is quite the beast to handle and very, very tricky to handle. So for certain kinds of measurements, these are actually favorable, right? Now you get some thermal expansion, and but it's basically, once it touches the part, it's the same temperature as the part. And as long as the, you know, these are steel. If you're measuring something steel, you're going to be pretty good, right? And a 48-inch micrometer takes quite a sense of touch to get a reliable measurement with. So I would say that most people would get a better quality measurement with something like this. So the other thing these do, and that's kind of interesting that I've used them for, is when you have a round cylinder that you've rolled up out of sheet metal, for example, right? And you've welded the thing together. Well, it's not perfectly round, so you're using your scale or your rule, and you're measuring it in a bunch of different, you're measuring it in a bunch of different places, and you're kind of doing is mental averaging to figure out what the diameter is, right? Well, if you just whip one of these babies around there, right, it doesn't care if the thing's not quite round, right? Excuse me, as long as there's no big hollows in it, right? You get good tension on it, you get an accurate dimension, right? So it's the true diameter, okay? Even though the thing might be slightly oval or elliptical or something like that, you'll still get an accurate diameter, because it's just measuring the circumference, remember? and then we read in diameter off of the scale. So let's, I'm going to get something and get a close-up of this, and then you can kind of see what the divisions look like in a little closer. All right, so let's try to do this without bonking my head into the camera. So I got it around the thing here, and I'm kind of reading it off at an angle here. So there's 4, right? So this is 3" 725 plus some, right? And I can't quite see it. It looks like the 10's lining up. So 3" 735 would be my call on this one. And in parallax excused here because I'm kind of off to the left here, which is not a optimal viewing angle there. But anyway, you kind of get the idea, right? And so I saw a guy using this to using one of these to measure the diameter of a train wheel. You know, like in fact, it was a BART train. And years and years and years ago, I used to commute on BART from Concord to San Francisco, and I was driving by the maintenance yard, or I was riding by in the train, the Concord maintenance yard, and I saw a guy in the maintenance bay. You know, we were kind of going through that area kind of slowly, and he was working on a train wheel, and he flipped this pie tape off of this train wheel. And I immediately realized what it was that he was using, right? And I was just so pleased with myself that I saw this from I don't know, 100 feet away or whatever, and I figured out what it was, right? And since I've seen that same method used to, he was probably just inspecting for wear or whatever. It has to be within a certain limit, you know, at the, you know, they're tapered a little bit, right? So I'm not sure where they measure them exactly, but he's probably just checking for wear would be my guess, because it wasn't a machine shop setting, so he was probably just inspecting them. So anyway, there's a pie tape. That's how they're used, and you know, like all measuring tools, it takes a little bit of finesse and a little bit of fiddling around to kind of get used to them, but very useful. You know, maybe a shaft on a boat. Something like that, where you can't get a micrometer on it, and but you could fish this. You could fish this around a large shaft or whatever, and get a measurement. Something, you know, access or large size or no availability for a gigantic micrometer. So, all right, this next one is that Jeff sent. This is real old school here, and what we have here. And it's red velvet. Oh, is there stuff under there? Huh. I don't think there's anything under there. Sorry. What we have here, this is called a planimeter. At least that's how I pronounce it. And this is kind of an old school instrument that kind of does calculus on the fly. Okay. And it's got a couple components to it. Now, I demoed one of these on a Meatloaf quite a few years ago, 5 or 6 years ago. Somebody sent me one, and we actually measured something with it. And what these are for measuring kind of irregular shapes, right? So if you have, let's say you had a map, okay? So a lot of this is for map work here. In fact, you can see some of the different scales here. 1 inch equals 25 feet, 1 inch equals 20 feet, etc. Look, I mean, look at this person's handwriting. It's just beautiful, right? Clearly European. They've got the commas for the decimal points, right? And it's just kind of old school handwriting. So let's say on a map you had a lake, you know, that would look like this, right? Okay, and you know, your job as a civil engineer is to figure out the area of that lake, right? Well, you know, modern times is pretty straightforward, right? But back in the good old days, you know, they would survey this, right? And what you can do with this planimeter here is you kind of lock it down and you follow this contour, and it'll give you an area, okay? Which is basically it's kind of integrating this this oddball shape, right? Kind of simultaneously, right? And giving you a solution for that. And now there's some ways of doing this kind of longhand. I think what's the name of that guy? Simpson's rule or something like that, where you can divide it's the foundation of calculus, right? So if you make these skinny enough, right, this little angle here, this little mismatch at the end makes not so much sense. Let's just put it that way, right? So anyway, that's what this little planimeter is for, right? And I haven't used one of these in ages, right? So I think this is the tracing arm here. So let's see if I can make it do something here for all those intrigued users. So it has two wheels here. It has a kind of a guide wheel, and then it has a totaling wheel here, right? So I believe you set this scale here, and then this arm, yeah, there we go, that goes like that. That goes in there, and then this is a fixed point here. So you trace simultaneously around, let's see, where's the other pointer here? You know what? I need to refresh my memory on how these get used here. Oh, so maybe that's it. So these are set at a fixed ratio depending on the scale of your map, and then you zero this little wheel, and depending on which direction you're going in relation to the shape, right? It's either the rate of change is changing. So that's the easiest way I can explain it in 2 seconds, right? And once again, I'd have to read again how to use one, but they're fascinating because they're purely mechanical, right? And you can do something like that and be pretty accurate, right? Which is pretty spectacular. So Jeff, thanks for sending that. That's pretty cool. This is like the third one of these that's been sent into the show, and I've got a little mini collection of these now, so a little library of them. So let's see. Let's go that way there. Let's see how this wants to sit in here. And I just love the box, right? It's got that smell of old instruments, right? Kind of a dusty antique shop smell. And I mean, for all I know, this could be ivory here, right? These scales, it's probably not, but yeah, it's not yellowed enough. It's still pretty white, so it's probably just plastic. Hard to say the date. Let's see, is there any date on here? Made in Germany. It's got a little tag on it here. Let's see if there's anything on that. Oh, here we go. Department 2, Engineering Mechanics, checked by Cal Yannell. So yeah, maybe it was at a school or something like that, and they loaned it out for students to use. I don't know. I love the label there. That's pretty sweet. All right. So Planimeter. Thanks, Jeff. Appreciate you sending that into the show. It's pretty awesome.